Hey everyone, I'm not able to be with you today in class because I'm giving a presentation somewhere else in the building. So I am here if you have questions after school and you want to come back around 3. I'll be back in our classroom. But for the sake of today, we are going to carry on in our note packet. So you could go ahead and get out your blue note packet and then also your ISN, your notebook that has the formula sheet in it. We're going to pick up where we left off, so we'll be on page 5 in the note packet. But before we go there, I want you to go ahead and take out your formula sheet, and I'm going to give you the 2 formulas for today that you'll need. Okay? Before we write those formulas down, there's something on our formula sheet that's called the slant height. So the slant height you'll deal with in a pyramid and in a cone. The slant height is the height of a lateral face. Okay, so you don't want to confuse it with the height that's from where all the vertices meet right there at the top of maybe a pyramid or a cone. It's not that height all the way down to the middle of the base. The slant height is the height of the lateral face. So in this case, it's the line that's drawn on the face. So notice how it does not go down to the center. We don't have a formula for the slant height. It's just a number that we need for the formulas. So the first formula is for a pyramid. The lateral area formula here is 1/2 P times L. And that fancy L represents the slant height. So notice I just put that in the formula sheet. And remember, P stands for perimeter of the base, just like in the other shapes that we were talking about, the prisms and the cylinders. And L stands for slant height. Okay, for the total surface area of a pyramid, we're still building on that lateral area, plus, now in this case, there's only one base. So now it's just the area of the base. And again, you have to decide, well, you can't really pick, you look at it to determine what is your base, what shape is it? Is it a triangle, is it a hexagon, is it a square? Okay, and then the other formula you'll need for today is a cone. So the lateral area formula for a cone is pi r times L. R stands for the radius, and L still stands for the slant height. So make sure in the diagram to the left you label R for the radius and L for the slant height. This line here going right in the middle, that's the actual height. But we don't want that height. We want the slant height, which is the height of the lateral face. Okay, then total area of a cone. Your formula, again, is building off of the lateral area. And in this case, it's the area of a circle. It's never going to change. So it's always going to be pi r squared. You could write area of the base, but there's really no point since it's always going to be a circle in a cone. All right, I'd still keep those out so you can reference back to them while we're filling in the notes. So go ahead and turn in your note sheet here, and we are at the top of page 5. Remember, at any point, if you need to pause it or rewind or go back and get stuff, feel free to. Okay, top of page 5 here. Label each diagram as a cone or a pyramid. So number 1, well, I'd have to say that's a cone since the bottom is circular. Number 2, it comes to a point, the base, the bottom, again, it's not a circle though, so this one would have to be a pyramid. Number 3 looks very similar to number 2. Again, the base, oops, spelled that wrong. The base looks like a square, maybe a rectangle. So it's definitely a pyramid. And number 4, the base is circular, so it must be a cone. All right, what is a pyramid? When we talk about a pyramid, well, we know it comes to a point, but what's different between that and a cone? We said a cone has a circle base. More importantly, a pyramid has triangular faces. And it's different from a prism because it only has one base that, again, is not a circle. Okay, so we talked in the formula sheet about the two different heights that you can have. You can have the regular height, like the altitude, that's labeled H in the picture here, or you can have the slant height. It's the line that's actually slanted. It's on the face. So let's clarify the difference between the height and the slant height. Now, in A, I see 3, I see 5. We could find this bottom part by doing the Pythagorean theorem, or maybe you see it's a triple, but we don't even need that. I need to know which one's the slant height. If you said it's 5 feet, you're absolutely right. That's the height of the face, and that face is a triangle. In B, the slant height should be 13 feet. Again, that's on the slanted part. C, I like how this one's written. It's a little bit harder to see, but think about it. What do you think the slant height is? Hopefully you say it's 10 feet. That's on the outside. 8 is the altitude height. All right, moving on here. Remember, we wrote the formulas down. Here they are again. You have to use them. Remember what P stands for, perimeter. The fancy L is slant height. And then you always have to look at your base. All right, top of page 6 here. Find the lateral area and the total surface area of the square pyramid. So I'd go through there, circle and underline important words, with a height of 12 and a base edge of 10. Okay, let's label things. A height of 12, that's not the slant height, that's the actual height that's drawn in there, so 12. And it says the base edge is 10. I underlined the word square earlier because the base is a square, which means every single side is 10, which is going to be important for lateral area. Lateral area again, 1/2 perimeter of the base times the slant height. 1/2 the perimeter of the base, 10 plus 10 plus 10 plus 10. It's going to give us 40 plus slant height. Now, the slant height is not drawn in there, so we have to draw it in there. Hopefully you're seeing this right triangle. Yes, you're right. If you're thinking we're going to have to do the Pythagorean theorem. Now we need to know what this little side of the triangle is. What do you think it'd be? Hopefully you're thinking 5. How'd I get 5? I cut the side in half. So if we do the Pythagorean theorem here, 5 squared plus 12 squared equals the slant height squared. We get 169 equals the slant height squared. Square root it, and we get a nice 13 here. So times 13. So again, we get 1/2 times 40 times 13. Ends up being 20 times 13, which gives us 260 centimeters squared. For total area, we want to build on the lateral area plus just the area of the base. So go back to the problem. Either you look at the diagram or you look at the words in the beginning. Well, it says it's a square pyramid, so the base is a square. So we take our LA that we found and add it to the area of the square, and that would be 10 times 10. So add 100 to it, and we get 360 centimeters squared. All right, example 2 here. Again, find the LA and TA of what this time? It's still a pyramid, but it says it's a hexagonal pyramid, which means the base is a hexagon. So let's label what we know. And this time we know the slant height. Thank goodness, that's great, less work for us. So draw it in. It also says that the base edge is 8. If it's regular, that means every single side is 8. Okay, here we go with our formula here. LA is 1/2 times the perimeter times the slant height. 1/2 times, well, perimeter. If it's a hexagon, it has 6 sides that are 8 feet long, times 10 for the slant height. So 1/2 times 48 times 10, we get 240 square feet. For TA, total area, we need the lateral area plus the area of the base. Now here's where you want to go back to your formula sheet, and remember, all the way down at the bottom, we have all these lovely formulas. And remember, right over to the right, we're looking at a regular polygon. So we need that formula, 1/2 A times P. Remember what A stands for, apothem. So remember, the apothem, it cuts the side in half. So 8 becomes 4 and 4. Remember what you put on the apothem, a lovely root 3. So we have 4 root 3 for the apothem. So total area is 240 plus 1/2 times the apothem, which is 4 root 3, times the perimeter. We found the perimeter earlier, it's 48. When we multiply this together, we still have that 240 from the lateral area, and now we have to add it to 96 root 3. In order to give me one full answer, you do have to plug it all in your calculator, and you get about 406.28 square feet. All right, I know we're going kind of fast here, but I kind of am on a clock. I'm only allowed to record for 15 minutes, which is good because I don't want you to be bored after 15 minutes. So I think we have about 2 problems left to finish, and then you have a few to practice on your own. So let's find the lateral and total area of a cone now. New formula for the lateral area. It's right in the box above. It's pi times the radius times the slant height. We are given everything. It says, hey, the radius is 3. Well, it doesn't say 3, or it doesn't say hey, but it tells you the numbers. So let's plug in what we know. Pi times 3 times 5. That would be 15 pi. Those of you plugging in pi and getting a decimal, that's okay as well. For total area, we need to take the lateral area plus the area of the base. Pi r squared, 3 squared is 9. So we have 15 pi plus 9 pi. That gives us 24 pi meters squared. Yes, the cones are a lot easier, and you'll probably end up liking them the best. All right, and then this last one together. Find the LA and TA of a cone. The diameter is 16. What does that tell us about the radius? Yes, that it's 8. Okay, in this case, the height is 15, not the slant height. What are we going to have to do? Yep, you got it, Pythagorean theorem. Okay, so I'm going to go through that really quick here, but you could go ahead and take your time, set it up now, make sure you got it right, maybe pause this. All right, after we work it out, we see that the hypotenuse, or in this case, the slant height, is 17. So the lateral area is pi RL. So pi times 8 times 17. That gives us 136 pi. And our units, centimeters squared. That looks good. And then for TA, total area here, we have the lateral area plus pi r squared. We know the radius is 8. So we have 136 pi plus 64 pi. And that gives us a nice even 200 pi centimeters squared. All right, I want you guys to go ahead and finish the rest of this page. So I want you to do examples 1, 2, and 3. When you're done, just go ahead and raise your hand, tell Mrs. Murphy or our sub that's in the room, and he or she will get you started on your homework. Okay, again, if you need to go back and rewatch this video or anything like that, it's posted on my website and you'll be able to access it the entire unit. Okay, if you have questions, please feel free to come in Wednesday morning and see me. If not, I'm here after school as well. Enjoy the rest of your day, guys.